Harihi Om, Andariki Namaskaramulu. Today is another good day. We are going to start a new topic. Just to recollect, we have started this course 2 months back in the month of March. And during the month of March, we had learned the Samskrutam basics of Samskrutam. And Pravesha syllabus is covered in that almost. And after that, we started with the Sanatana Dharma topics. And we have covered so far Vedas, Vedangas, Upanishads, Darshanas, Dharma Shastras, and now Sanatana Dharma, what is it? And then Sodasa Samskaramlu. Now we have come, we also had two tests, one on Sanskritam language. Those all practice tests, and another one is on whatever is covered during the first month of this course. Now we are in the second month. Second month we finished with Swadava Samaskaramulu and then now Vedic mathematics. We are going to have a week's program on Mahabharatam. After that, Ramayanam. And then few other topics like Panchangam, Vastu, and Ayurvedam, and then some research topics. Like that, it will go on this month, and also we're going to have a practice test. And also we are going to have a final test in Sanatana Dharma related topics. Then we will switch over to next month yoga. Yoga again 1 month course in which we will be knowing both theory and practicals. We have done some 7 chapters of Bhagavad Gita. The remaining chapters will also be covered during next month by the same speaker, C.S.R. Prabhu. So after that yoga classes, we are going to have yoga theory and practical. Practical will be with the help of videos, and even yoga training is also online. Everything we are doing it online. You can sit at home at your convenience and then concentrate on the subject. This is so far is the review of whatever we have done so far. Now we are going to have the new topic, that is Vedic mathematics by Gautham Mukherjee ji. He has been taking this class for last 7, 8 courses. Now we will start the session with Vande Mataram, and then by Vande Mataram by Chala Chittibabu Garu and Prardhana by Krishna Kumar Garu. After that, I will introduce the speaker very briefly, and then we'll go ahead. So request Challa Chittibabu Garu to chant, to recite Vande Mataram, please.
Vande Mataram, Vande Mataram, Sujalam Sufalam, Malayaj Sitalam, Sasya Syamalam Mataram, Vande Mataram. Subhrajyosna pulakitayamini pullakusumita drumadala shobhini suhasini sumadhura bhashini sukhadam varadam mataram vande mataram Vande Mataram.
Vande Mataram. ధన్యవాదములండి. Let us request Krishna Kumar Garu to chant Prarthana, please.
Sarvebhyo Namaskaraha. Let us meditate for a minute. Close your eyes. Relax your mind and body. Take deep breath. Focus on it. Just chant Omkaram 3 times. Om. ॐ गणानां त्वा गणपतिगुं हवामहे कविं कवीनामुपमश्रवस्तमम् ज्येष्ठराजं ब्रह्मणां ब्रह्मणस्पत आनः शृण्वन्नोतिभिः सीदसादनम् ॐ श्रीमहागणाधिपतये नमः। ॐ प्रणो देवी सरस्वती वाजेभिर्वाजिनीवती धीनामवित्रयवतु। ॐ श्रीमहासरस्वत्यै नमः। गुरुरेव गतिः गुरुमेव भजे गुरुणैव सहास्मि नमो गुरवे न गुरोः परमं शिशुरस्मि गुरोः मतिरस्मि गुरौ मां पाहि गुरो। ज्ञानानन्दमयं देवं निर्मलस्फटिकाकृतिम् आधारं सर्वविद्यानां हयग्रीवमुपास्महे। श्रुतिस्मृतिपुराणानाम् आलयं करुणालयं नमामि भगवत्पादशङ्करं लोकशङ्करं शङ्करं शङ्कराचार्यं केशवं पादरायणं सूत्रभाष्यकृतौ वन्दे भगवन्तौ पुनः पुनः। ईश्वरो गुरुरात्मेति मूर्तिभेदविभागिने व्योमव्यत्याप्तदेहाय दक्षिणामूर्तये नमः। असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा अमृतंगमय। ओम शांति शांति शांति। मातृदेवो भव पितृदेवो भव आचार्य देवो भव अतिथि देवो भव। ओम सहनाववतु सहनौ भुनक्तु सह वीर्यङ्करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै। ओम शांति शांति शांति।
ధన్యవాదములండి కృష్ణ కుమార్ గారు. థ్యాంక్ యూ సో మచ్. Now I briefly introduce the speaker, Shri Dr. Gautham Mukherjee ji. He is MSc in Physics from Burdwan University, West Bengal in 1977, and he finished his PhD in Physics from Indian Institute of Technology, Kanpur in 1986, and he joined National Informatics Center, NIC, in 1990 and retired from there only after 36 years in 2016 from the post of Senior Technical Director. All throughout, he has been interested and tried to follow Sanatana Dharma, and his interest is in Vedic mathematics in particular. With this very brief introduction, in fact, he is part of our family of Veda Samskruti Samiti, and he has been the Acharya of all the courses in Vedic mathematics, for all the courses which are run by VSS so far, about 7-8 courses. And one thing more is that he has been a student of all these courses as well. So he has got, those pin numbers. I can see 1, 2, 3, 4, 5, 6 pin numbers. Every time we rejoin, a person will give him new PIN number. So he is a keen student and also a very good teacher for all of us. So let us welcome him and request him to teach us Vedic mathematics. Gautham ji.
धन्यवाद Colonel Babu. So I will start my PPT presentation. So this is just in the first level course. This is introduction to Vedic mathematics. I have given my contact numbers. Anybody can. I have shared their presentation also. Now, first let us start the origin of mathematics itself. It starts with counting, and there used to be some marking on the ground, like these lines on the ground, and maybe in the units of 5 there used to be some another procedure so that these 5 units can be counted easily instead of counting all the lines. Thus came various concepts of representing those numbers in different forms. In Babylon, there were 10 were actually used, but actually not a it was not a proper number system. The Roman number system we still use in another one, that's in ordinal numbers. It is with some symbols like I, V, X, L, C, D, and M, and so on. So they have some values, each of them. And lower value, upper value, left and right, sometimes it becomes addition or sometimes subtraction. If the lower value comes to the left of a higher value. But those numbers, actually, there are concept of cardinal and ordinal numbers. Cardinal number is the numbers which we use for calculation, and ordinal numbers are for labeling something with first, second, third, fourth, and so on. So mathematical calculation can only be done with cardinal numbers, although their representation is different, but these Roman numbers are still used as a ordinal numbers. And but that doesn't mean everything can be used as ordinal numbers also, numbering. And there is a like pin number, Asan number, etc. we use. Basically, those can be called also bank account number and so on. Those can be called as ordinal number because nothing called the two bank accounts cannot be added, subtracted, or multiplied like that. Now, now the various number systems are used in different parts of the world. But ultimately, the present number system that we are using is actually originated in India. Although, so this is called place value system. Place value system is actually this means that this came in 6th century and then Europe is spread to 7th century and then this in Arabia it came to 6th century and then finally to Europe to 7th century and then by 8th century that was the dominant number system throughout the world. But these are misnomer was that they are called Arabic number systems. Actually, it is totally invented in India. And there are actually 9 symbols, 1 to 9 are used to denote numbers, symbols. When some place has no value, doesn't contain any value, the heavy dot was put there. So that is the discovery of zero. We sometimes refer that India has discovered zero, but not that. India has discovered the whole number system itself. Zero is only one small part of it. Now, this has become the base, natural base is 10 because we have 10 fingers. Now, how the zero actually became a part of the calculation, it becomes actually Brahmasputra Siddhanta by Brahmagupta. It actually it found some property of zero, like that zero is how subtraction and addition gives same number. It doesn't have any effect. zero number, same number subtracted is 0, and then when 0 is added or subtracted, it doesn't have any effect, it returns the same number. Whereas multiplied by 0 becomes 0, or division from 0. But square root, of course, is square root 0. But division by 0 was not correctly handled still. So sometimes, even sometimes people tell that something divided by 0 is infinity. But actually, later the concept came gradually that we know as it of today. This when the calculus came, that 0 actually is do not call division by 0. We call it when the limit of a number and divided by a small number, the small number approaches 0. This whole result approaches infinity. That is a different limit concept is there. That is it came much later. But there is a proof that since calculus also came in India, so there may be some concepts that time it came also. Now, the base is very important in the positional number system. As I told, this is called decimal number system because we use 10 as base, and this it is found because of 10 fingers we have. It is found to be most natural base. We count numbers 1, 2, 3, 4, 5, 6, and then form the numbers based upon that. But with introduction of 0, that is very important. That number of total digits, number of total symbols or digits, what you call, is the same as the base number of the base of the number system. Like we have 10 symbols, 0 to 9, and then we have the 10 as a base, so it becomes same. But when computers came, it is found that most suitable number system for computer becomes binary, because in the circuit there can be only two kinds of states, like voltage is flowing or not flowing. Some low voltage is there or high voltage. Low voltage is nearly called 0, or high voltage is called 1. So 0 and 1, these things are. Or suppose a switch, we consider a normal electrical switch. It becomes either it can be off or on. Off is called 0 and on is called 1. That way, for most in computers or in certain devices like switch, I have told, binary becomes most natural and dominant number system. However, binary actually to keeping track becomes difficult. Always 0, 0, 0, 1, 1. We do not find any value to that. We always have to calculate in the background and cannot use it properly. Then comes the higher values called octal. When the there was a earlier version of computers, first they grouped into 3 numbers in octal. The digits are from 0 to 7. But however, present day computers, they use the binary numbers grouped into 4. So it becomes 2 to the power 4. So octal was 8 because 2 to the power 3 is 8, and now it is 2 to the power 4, means 16 is the base. So it is called hexadecimal number. However, the digits are, we have only 10, 0 to 9. So there are introduction of, there was A, B, C, D, E, and F, this 4 only, right? This 6 only, not G, H or something like that. Only A, B, C, D, E, F, these were used as numbers. They have, like A has value of 10, B is 11, up to F is 15. So that was the hexadecimal system. And that is only used mainly in computer. However, all the principles that we will teach here can be applicable to any number system, including the hexadecimal. Now, there is a concept of place value and face value in number system. As you know, we already know these things. It is just a revision, you can say. Place value are, we call them unit, 10, 100, 1000, etc. Their powers of 10, 10 to the power 0, 1, 2, and so on. And then we suppose a number we take as 756 only, 7 into 100 plus 5 into 10 plus 6. Where 7, 5, and 6 are called face values, whereas these are called, this will take unit, 10, 100, etc. called place value. So those are when you multiply and then add, it becomes the actual value of the number is returned. Now, negative 10 power. you know it is already we use. It is called fractional expression, or it is actually decimal notation. 0.34 will be 3 into 10 to the power minus 1, 4 into 10 to the power minus 2. It should be beyond unit. After unit, towards right of unit, we put a dot, maybe a dot like this is called decimal point. And then whatever we write, it becomes gradually diminishing powers of 10 in the negative side. And however, negative phase value in modern mathematics is not known. Use is not known. This is was used to be used in basic mathematics, and there is a concept of not should be used to be, I should say, because the Bharati Krishna Tirtha has revived the Vedic mathematics from his own practice and sadhana, you can call, and then this vinculum is used in Vedic mathematics, and then it has a lot of power in handling certain situations. Now, these symbols, English, these are the form of symbols 0 and 1 and 9, like this way. But actually, there throughout the world, there used to be various, wherever the place value system is used, throughout the world, they use this 10 as a base, and then the next slide we'll see that what is the different your symbols throughout the world are used, especially Indian states. Lot of various states use various symbols for number system, and they all have how to write them on computer. So there's a Unicode system has been devised. Unicode is a very general coding system. Those of you who understand computer can understand each of the even alphabets of all the world have some or other Unicode system. That way they can be represented, and they can be written like what even mobile we are using, say Telugu, Bengali, Hindi, all these things, letters. Those letters have some background Unicode value. Those are handled in the computer and mobile devices. Is my voice loud? Is it adequate?
Yeah, it's okay. Go ahead.
Achha, now, this English number system, they have ASCII value. ASCII was the earlier system. And before Unicode, there only ASCII used to be used. That's called 30 to 39 hexadecimal, and decimal 48 to 57. Those just to understand. But then there are others one actually. Others are found that those numeric characters in Unicode, even they can participate in the calculation. Where some countries like Chinese, etc., they do not have any such numeric values which can participate in number calculations. Now, in the next system, and how to display those values, there is a MS Word. In MS Word, you write that hex code. We'll be displaying what is hex code, followed by Alt X. Press Alt in the keyboard and X together. So immediately that will be displayed. So these are the numeric symbols in India. So like Hindi, suppose you want to display this Hindi 0, you have to write 0966. This is 1, 0967. If you write and then press Alt X, this particular symbol will be displayed. Normally what we are doing, we are setting the keyboard to Hindi, English, Telugu, whatever it is, and then in the number, if you can press the keyboard, it automatically displays. But in the background, anything can be, any character in the world can be displayed by using the hex code, writing a hex code, and then alt text. Yeah. So suppose Telugu this Telugu 3. So suppose Telugu 2 I am to display. 0668. You have to write and then alt text. You can display this number in on that way. These are the all the Indian numbers are there. And then next slide, there are all the English are of course the most default one, and then Arabic, Thai, Lao, all the different other countries to have different numbers, which all can participate. And like to earlier the Tamil, Telugu, and so on, all the Indians, these numbers can participate in the calculation and can put total Excel sheet we can make with the calculation of these numbers. Now, Vedic mathematics. Now we come to actually the main topic, the Vedic mathematics. It is actually intuitional use of 16 Vedic sutras and 32 sub-sutras, but later only 13 are used, and others are maybe may not be that important, or the corollaries, and they're sometimes there that may not be used that much. And then originally, according to Jagadguru Swamiji, he studied a lot. He mentioned that in Atharva Veda, some kalpa, actually it is mentioned. It is there, started with some mathematical concept. And these are actually, these sutras are used for tackling various mathematical problems. However, the present version we use in the Vedic mathematics, these are the result of 7 years of deep study or sadhana I can call by Jagadguru Swami Sri Bharati Krishnaji Tirthaji Maharaj, whose book actually is available in Amazon around 200 rupees. It's a very good one. I'll show you the book. This is the book. Now, this Vedic mathematics is a collection of various alternative methods solving some mathematical problems. In practice, it has potential to develop better control on the number system. That is the thing. Actually, arithmetic, now at the present day, it is called number theory. Arithmetics is this term sometimes referred to as number theory, and there are research still goes on with number theory or arithmetic. So these can contribute in the research also, Vedic mathematics procedures, and they can be having better control on the number system. And the Vedic mathematics aims at developing mathematical intuition in choosing the best method. So whatever, giving the particular situation, particular combination of numbers, and you suppose you use addition or subtraction or multiplication, division, what will be the best method, choosing the best method to be chosen to done most effectively that particular calculation. So only if we only choose like what we are doing in the school now, only one or very few methods that we are learning mechanically, and then we do not want to learn beyond that. It should not be the case. We'll see. This is the book I was referring. It is slightly faint in the bottom. The Jagadguru Swami Sri Bharati Krishna Tirthaji Maharaj. You can see it. And then this is available in Amazon. Now this is one page, some page photocopy from that book only. These are the 16 sutras, main sutras. Egadhikano purveno, one more than the previous. Nikhilang navatas charamada sutra. This means actually all will be subtracted from 9 except the last one, charamam. Last one will be subtracted from dasata, from 10. Urdhva from slant and straight upwards, and as well as slant. Paravarta judges. There is transpose, etc. Transpose and calculate, something like that. These all have meanings. I have in some slide I have put. Now, these are the 13 subsutras. These are Unurupena and so on. These are just photocopy from that book. But there are some whatever I got this. But I'm sorry that all the meanings I didn't get for all the subsutras and so on. You can just go through this presentation given to you. I do not read it, repeat it here. Transpose and apply, one more than the previous, as I already told, 9, all from 9 and ultimate from 10, with upper slant and transpose and apply. And these are so many, in different situations of calculations, different those formulas are used, normally are used. Then Charana Kalana, you know that Kalana means actually differentiation. So these will be different. We have 16 sutras meaning, and then there will be sub-sutras. Some of them I got, but all of them I didn't get. There are many subsutras actually. Some these are the all the things. 13 maybe. There is one extra. Some actually corollary becomes actually one extra. Now these are the what is the scope of basic mathematics? There various arithmetic computation can be done, multiplication, division, recurring decimal, divisibility. These we will cover in our course. The highest common factors, square root, cube root, equations, factorization and differentiation and integration. These all the latter after divisibility. Others will be kept for the second level course. Some of them, and we will see it. But in the present course, we will be doing arithmetic computation means the addition subtraction also included. These will be we will be focusing on these mainly. Now there will be addition subtraction multiplication division. The conventionally taught there only some they have some other algebraic background. We sometimes do not. We may or may not learn those algebraic background, but we already we know how to do it. I mean, since childhood we just learn it. Do this, and then we get the result of division, say multiplication, and so on. But once the inherent algebra is changed, the procedure or method gets changed automatically. But we do not learn normally, but in this session we will learn that there are alternative procedures. In basic mathematics, here I just introduced that vinculum concept. Both the positive and negative phase values are used. I already mentioned, but when the digits become more than 5, sometimes equal to 5 also, there are cases, digits are more than 5, then the negative phase value is used, called vinculum notation. So 48 can be expressed as 5 and 2 over a bar over 2. We call 2 vinculum. We'll call 2 vinculum. Actually, its value is -2. How? Now 48 is 4. This is 4 is in tens position and 8 is in unit position. So 4 into 10 plus 8 is 48. However, 48 can be written also as 5 into 10 minus 2, because 8 is more than 5. So we better to will be comfortable in using 2 as a digit. So we write express as 5 into 10 minus 2, and we use represent that number as 5 with vinculum 2. So how to do it on vinculum notation and vinculum the conversion between these things? This is a technical difficulty. So Unicode has done so many things, but they didn't consult any basic mathematics expert or somebody while designing that Unicode. Otherwise, there could have been numbers with bar automatically in the Unicode. But here, there is a particular, this Unicode symbol, this vinculum symbol, bar above is used, and it is very cumbersome. I had to sometimes draw it, and it doesn't become very efficient. So anyway, with whatever is available, I tried at as much as I can for the notation. Now, how to convert? What is the conversion procedure? 6 is equal to 10 minus 4. So 6 can be represented as 1 and 4 vinculum. 10 minus 4, so it is vinculum. 97. 100 minus 3. It is can be used as a 1, 0 and 3 of vinculum. 143 vinculum can be expressed when we remove the vinculum. It becomes 143,000 minus 143,142857. Now, the main procedure is that when we transform something from clear the vinculum from one to another, we do that Nikhilam Navadasthana, means that everything is getting subtracted from 9. 9 minus 1 is 8. 9 minus 3 is 6. 9 minus 2 is 7. 9 minus 4 is 5. And 10 minus 4 is 6. You see, therefore, 13244 becomes 86756 using Nikhilam Navadasthana. Then you have to do Ekadhikano Purveno. In case of here Ekonunnan becomes. So 3 will become 2. 3 will become 2. Whereas when I have to express something, a number will be expressed as vinculum. A given number will be expressed as vinculum. We apply ekadhikano purveno. Okay. Sometimes the ekadhikano purveno, ekonunno purveno is there also. So when the whole range of vinculum ends, we add one number to the immediate previous one. We add, and whereas we clear the vinculum, we subtract. This you have to understand. But in the background, as you know, this is our known mathematics. We know that is known mathematics. We do borrow and so on and so on. But actually, this borrowing, etc., don't have to mind. Only I'll do Nikilam Navata Stanamang Dasata. That will take care of all the borrowing and so on. And finally, when you are clearing this, actually becomes Ekonunno or Ekadhikano, as the case may be. So we can just practice it. We just understood that algebra, and then you can easily apply. You will not have any confusion. As was told earlier, vinculum means negative face value. Now, it says that only up to table of 5 into 5 will be sufficient in learning the vinculum. This reduces the effect of calculation. Again, for example, this one. How these are doing? This can be done. So here we give an example where all these things are except this thing, initial first one, all these are above 5. So I can convert all these things up to above 5. Here, if we do, there's a lot of additional. Suppose there are more numbers. Only 4. There can be more numbers. So 8 plus 9 plus 7 plus 8. A lot of keep track of a lot of things like this. Whereas when they convert into vinculums, this becomes small numbers. Okay. Here also Nikilam Navatastan 9 minus 9 is 0, 9 minus 6, 9 minus 7, and 10 minus 8. That way you got that. Like all we got. Now here we simply add 2 plus 1 plus 3 plus 2, immediately got 8. 2 plus 1 plus 3 plus 0. That way all becomes, our effort becomes less. Finally, we again, what we do, this way, we again do it. Nikilam Navatastan 9 minus 6 is 3, 9 minus 4 is 5, and finally 10 minus 8 is 2. We write this 3, 5, 3, 2. And when converting back, it becomes 14, becomes 13. So in the background, explanation is like this. Explanation is that all the zeros are there, this becomes 14, and then all these small numbers, this becomes like this, and then finally when we subtract this. Actually, this, instead of doing this, we just automatically do by vinculum methods. With practice, we get practice, we'll get much easier. You will get. You always have to think of borrowing and so on, carrying. Here we have to just by Nikilam and Avatascha, the effect of the borrowing method in the subtraction will be automatically taken care of. Here another example is there. We purposefully put a different sort of combination where this becomes negative and positive cancels. So this 9, 2, the position of the vinculum becomes alternative, like this. Here it is, here it is, again here, again here. The vinculum position and positive positions changes. So here becomes 4 minus 2 plus 2 minus 4. It becomes 1. Minus 3 plus 5 minus 4 plus 3 is 1. So that way it becomes very, effort becomes 3 minus 3 cancels. 4 minus 2 is 2. Minus 1 plus 4 minus 2 plus 4, only this 5. So that way, sometimes it may be negative also. That time you have to do, here the example I have taken, all becomes, result becomes positive. So it becomes exactly directly event. In the explanation, we cannot directly explain nicely. Therefore I crossed it like this, and we can say that it is like that almost. Now there are small tips or tricks, you can say. These are used in, sometimes we see that most popular in basic mathematics, see these small tricks are used. Like what we do, the algebra is I have given past, but the procedure is like this. 15 square, 1 into 2. 1 and the next one, 1 into 2, and then we write 25, 225. 2 into 3, and then 25, like this. 35 square, 3 into 4, 12, and then 25. So that way it goes within minutes you can, within just seconds you can calculate there. 5 into 6, 30 to 31, then 25, like that. But everywhere there is a algebra background. Now we come to our main topics of regarding multiplication. What is the multiplication near a base? The base is that power of 10. Power of 10 is called a base in case of both multiplication and division in this Nikilam. These are called Nikilam method because we will be using Nikilam sutras. Like this example I take first, 97 into 93. Now 97, we do this Nikilam method. Why Nikilam method? 9 minus 9 is 0 and 10 minus 7 is 3. Here also 9 minus 9 is 0 and 10 minus 3 is 7. We write like this. Or you can say that 100 is the base. 100 minus 97 is 3, 0, 3. And in fact, this Nikilam method requires that same numbers of digits should be preserved here. Or the same number of zeros at the base. So therefore, it is Nikilam method you can better call. Sometimes we should not write minus 3. Rather, I should write minus 0, 3. Here also minus 0, 7. Now, the procedure is like this. Here we do 97 minus this 0, 7. This we do. 97 minus 7 becomes 90. Or same as 93 minus 3 is 90. And then 3 into 7 minus plus becomes so 21. 9021 becomes my answer. As easy as that. Here we do higher numbers, higher base. 1000, near 1000. 997, give the same, take the same example. It becomes minus 003. 9 minus 9 is 0, 9 minus 9 is 0, and 9 minus 7 is 3. 10 minus 7 is 3. Like here also, we write minus 003, minus 007. Becomes 990 and 021. 9997 also. As you write that increasing more 9s should be increasing more 9s here and more 1 0. Suppose you increase more 9s, it will become increasing 0. So another example I have taken for the base is 10,000. 9876, it becomes Nikilam Navdastar 9 minus 9 is 0, 9 minus 8 is 1, 9 minus 7 is 2, and 10 minus 6 is 4. And 9987 becomes 0013. We multiply, then can be method using Nikilam also you can do, but here also I just multiplied it like 16120. And 9876 minus this 13 becomes 9863. So 98631612 becomes my answer. What is the, now let us take, anybody can tell, suppose I take 9, 8, 3. And 9, right? Somebody may, people may use your copy, right? 983 into 987. Please try. (983) into 987. What should I write? Minus Nikilam Navadas, Sarvadasra 017. Or 1000 is the base, 1000 minus 983 is, and minus 013. Like this. Here the first part becomes how much?
983 minus 013. That becomes 970.
Becomes how much?
97.
970.
221.
970
Is 221. 7 into 13 is 221. This becomes my answer. We introduce more 9 here. Obviously, another 0 will be introduced here. As a result, there will be one more 0 here. As a result, there will be one more 9 here. So it is like this. Imagine it is doing give a student of say 6th, 7th, 9th standard. Normally 9th standard they may not do. They will do more in all algebra. Give a student. It will be they will be so much effort has to be there in the conventional method. Now, what is the algebraic explanation? Algebraic explanation is that this we consider the first part. This we consider as it is a n minus. This is suppose we call it A, and this as B. This 3 is A and 7 is B. So this is already n minus A. I have to multiply n minus A, this one, with n minus B, this one. What we do? This algebra can be done as n into n minus A minus B. So we find that n minus A minus B. N minus A minus n, it is already n minus A. When I again subtract this B, it becomes n minus A minus B. N minus A minus B or n minus B minus A, same thing. And then this is the AB part. This is the AB part. This is the AB part. And this n minus A is this part. And what is the effect of multiplication by n? This is actually the shifting of these many decimals. This is the effect of n, means that base. Base is my 10,000 here. So 4 digits, 4 zeros. So 4 digits it becomes, it doesn't get mixed with this one. This remains separate by putting it towards left, 4 digits. So this is the effect of multiply with capital N, means base, and then becomes n minus A minus B, because it was already n minus A, n minus B, and we again subtract, and then A into B. So very clearly, the very judicious use of this particular algebraic expression. But we've seen that in the modern mathematics or say classrooms, will not normally people will not discuss. It is not in the course. Somehow it is got expelled from the course. It is people algebraic expression they learn, but how it can be this particular formation, they will just do it n square minus A plus B into n and A plus AB. But how to express it in this format and then how to use this particular formula in case of multiplication, how to efficiently we can do special cases. These are cases actually. Near to base, near base. And near to base, it will be easier. As you see that is slightly away from base, it will be, suppose it is away from base, there will be more calculations required. Here, near to base, but near to base becomes more nines, and this becomes more difficult. But people do not understand that there is an alternative method. When something becomes near to base, it becomes more easier in this method, not more difficult. So that is the idea of a different framework of learning alternative methods. Case-to-case basis, you can do it. Best method you can choose. Multiplication near base above, like this kind of numbers. 1 0. Here, a lot of zeros, people will say that, okay, zeros you can easily handle, then conventional method is also okay. So then, okay, then this previous one is, therefore, I discuss first. Like 103 into 107. It becomes again, it is, again we write plus 03 and plus. Here extra is found, so this nickelum already is called in general nickelum, but it's not. Nickelum is not required here. Plus 03 and plus 07. We preserve the same number of zeros. It becomes 103 plus 7, so becomes 110, and then 3 into 7 becomes 21. Like exactly this we did in the negative case. 1007 and 1003 becomes 007, 003, and then result becomes this 1007 plus 3 becomes 1010, and it becomes 021. So this is the total. This is also the same kind of example is being used, so that it is seen that increasing more number of zeros in both multiplication result in addition of the same number of zeros in the first part and same number of zeros in the second part. So this is this one, this into 3, and so this also algebraic expression is that n plus a into n plus b becomes n into n plus a plus b. This is already this is a and this is b. This is a and this is b, and these are the n plus a already. This is already n plus b, and this becomes n plus a plus b. And this is becomes my AB part, so this becomes the result. And shifting any multiplication of this n becomes result in shifting towards left. So this is that example, and I proceed further. Now come to multiplication near a base but mixed. One is below base and above, other is above base. So we start with this. 97 becomes minus 03, Nicola we can apply, and 107 is plus 07, minus 07 and plus 07. It becomes that 93 plus 7 or 107 minus 7 becomes 100, and the 7 into 7 becomes negative 49. This 49 we write with a vinculum. Now how to clear vinculum? It becomes 10049 over this, or becomes, then again becomes Nicola now the 9 minus 4 is 5, 10 minus 9 is 1, and becomes 100 becomes 99. Or you can say 100, this base is 10000 minus 49 is 9951. It's basically this one, or by Nicola method or by carry and this borrow method, you can do it. Similar to the higher bases, 1000 becomes 1013 and 993, 1013 and minus plus 013 and minus 007. It becomes 1013 plus 7, 1006. Oh, sorry, 1013 minus 7 becomes 1006, or 993 plus 013 becomes 1006. Same thing, 091 negative, and then it becomes 9, Nicola now 909, and this becomes 6 becomes 5, or 9995 becomes, and then Nicola now 99, then 7, and 10 minus 1 is 9. So it becomes like this. Here you see that 0 and multiplication, addition becomes more zeros in the 9 in the first part and 0 in the second part. Now instead the base, then plus a and minus b here it is. Same thing, n plus a minus b and minus ab. This is the most important. So far we had plus ab, now it is become minus ab. So this is the only thing. Okay. Now there is a concept of sub-base. Sub-base is actually when, so far we had used the number near a base. Now we come to sub-base. Sub-base, it is near to a particular fraction of a base. Suppose it is near to 500. So we identify that it is a near to 500. So 4833 becomes minus 017, and 497 is from the sub-base is 500, minus 003. Here it becomes, we write, do similar thing, 483 minus 3 becomes 480, or 497 minus 17 is 480, and this is becomes 051. However, Now, since we have done it, this sub-base we have used, you have to do, this is a fraction, so you have to divide it. So it becomes 240051 becomes the answer. Here we are using 5 times the base. Suppose we choose base as 100. Same problem can be chosen with base 100 and sub-base 500. So 5 times the base. So to multiply with 5, it becomes the same result you get. You are also, here you have to write, since the base is having 2 zeros, you write, there is no 0. This was 017, but here only 17. Minus 17 into 3, 51. It becomes 483 minus 3, 480. Then we multiply with 5, 2400. Result is same, of course. Consider above a sub-base. Here also you see that likewise 17 to 3. Similarly, we subtract, divide. Here we multiply. Now one is above, one is below. 7 into 7. Here it becomes this 490 divided by this thing, 245. And then 119, it becomes 245119, becomes 2444881. However, if we do here this base we use, here 190, there is no place for writing this this part. So the 1 becomes carry, and then this gets added to this one. It becomes 2451. 1 of course is vinculum. So here it also becomes the same thing. This actually becomes the same thing as this one. Now another example of the sub-base where you use 250 as because these are near about 250. So here you also see that easily you have to divide by 4. There is some challenge comes when by division results in fraction. So fraction, you have to understand how the fraction in a particular place in different, accepting not only in unit, but normally we use fraction and the whole number and then a fraction. But fraction can also, in basic mathematics, during the calculation, fraction may come in between digits also. Like this example, 18 into 45. The base is 100. Sub-base is 50. So 18 is actually 50 minus 18 is minus 32. And then 50 minus 45 is minus 0.5. It becomes 160. But however, this 18 minus 5 was 13, and or for same thing, 13. And then this, when we divide by 2, it becomes 6.5. And this also has a carry, because this doesn't fit over 2 digits. So 1 becomes carry. Now, how to handle this? Now, this becomes, how it becomes? 6.5. 6.5 means 6, and then this contributes, 6 actually was in 100%, so 600. The half is there, will contribute 50, half of 100, because it is 100%. So it becomes 50. And then this becomes 160, because 160, because it has a carry. This becomes 210. We can write also like this, 6 and then 2 like this. Then ultimately what happens? This 2 actually added to this 6 one. Or you can say 600 plus 210, same thing. So it becomes 810, because this contribute this one, added, carry is added, 8, and then becomes 10, like this, 810. So how this half, etc., half in 100 position means 5 in 10 position. 5 in 10 position means 50. Now, algebra is that here we are doing this sub-base. Sub-base is by multiplying dividing. Suppose m is half. So half n minus a. So this becomes half n minus a into half n minus b. This one. We do half n, we have to do. And then half n minus a minus b, this becomes half n minus minus n a minus b. And this becomes ab. But this is half n So you have to again do this half n, you have to write this half with n, you have to write this n will contribute shifting towards left, but again you have to, this particular position only, this part, not the AB part. This has to be divided by, in case of half, it is divided by 2. Suppose you have multiplied, earlier we have multiplied by 5, you have to multiply by 5 here. So that is the idea why you are doing this aim, this position of this aim. Now we come to the another method called Tirjak, Urdu Tirjak. So far you have discussed, is clear? Any question from whatever you used, learned so far? So we can get from reaction from my participants.
After studying this a little bit, we may have some doubts. Now, when it settles down in our mind, then we may have some doubts.
You can practice it. You can take your frame your own example, and then try to solve it. Solve it in line of the. It is given to your circulated to the PPT circulated. You can just go through it. All the book, if I purchase that book, also you can give that.
Do you need?
You can suppose you have doubt or you are not getting. You can always verify using other methods like conventional method, or you can use calculator from your mobile and verify that whether you are in the right track or getting the correct result. And then you can see what is the mistake, and then we can discuss later. Or you can privately, you can also interact with me. I mean, I have WhatsApp number I have given already. Say this one, this you can.
Do we need to buy that book?
Huh?
Do we need to
you can get the book in Amazon.
From Amazon?
225 or something like that. 225 for hardbound and 175 for the paper. That was some days ago. But maybe it shall be revised, I don't know.
It is not compulsory. If you want, you can buy. Otherwise, the PPT is sufficient for you to do the whatever the exercises.
Okay, sir. Thanks. Thank you very much.
Okay, thank you.
Sir, can you go back to the 2 slides back and sub-base 500 you explained, sub-base.
This one? This one?
No. Just next, the next one, sir. This one. This. Can you explain this 2 division? 520 you got 260 and 051. Can you please once again repeat this one?
As 500 is half of the base, we have to make half. In the algebraic expression, remember that m, presence of m, is a multiplication factor. Here the multiplication factor is half. 100 into half is 500. So you have to do, again we have to do 520 into half is equal to 260. Like that.
Dhanyawada, Guruji.
Thank you. This is the presence of this m. M is actually how m is being used here. Okay, so we go to now next topic. Now conventional mathematics we use, normally this is the most general one. This is not near a base or something like that. The base is not considered here. Here is a general multiplication. What we do in our conventional multiplication, we do in the first line, we multiply everything by the total top gets multiplied by 5. It becomes now 213. And then you write, so we write 213 when you multiply by this thing. and we shift one number, 40 becomes 46, 86. 86, and then we add, becomes 3, what did you, oh sorry, 215. So it becomes 5, it becomes 7, and it becomes 10. That is our procedure. Instead of that, this is found in calculation, as I told, that there is another method you can do. How? Now, unit digit is formed by unit to unit, like this. If B is unit here, D is unit here, we do BD, that is the unit digit. 5 into 3 becomes 15, and then it has a carry, so we write it below. Now this tens digit can be formed by multiply 10 into 1 or 1 into 10. 1 from unit from this one and 10 from this one, or 10 from this one and unit from this one. So this is called AD plus BC. And so this becomes like this. So what to do? 4 into 5 plus 3 into 2 becomes my 26. So 26, this earlier 3 into 5 was 15, like this, 15. 26. I have 6 right here and 2 as a carry, we write left. Because it will add towards the higher place value of the another number. Then this becomes AC. This tens digit into tens digit becomes 100 digit. So 4 into 8 is therefore called Urdhva and Tirjagabham. This is Tirjagabham and this is Urdhva. This is Urdhva, this is Urdhva. So that is Urdhva Tirjagabham. We write like this and then we 5, 6 plus 1, 7, 8 plus. With the research, it is found that number of processing is less here compared to our conventional method that we have shown here some time back. So this is actually, it is less. Therefore, it will finally it will save the time and then computational time, computational effort, and then it will save power. So megawatts of power may be saved throughout the world. All the calculations that are being used in all the devices in the background. So that way. So procedure is clear. Let me discuss more so that so Urdhva Tirjagabham. For 3 digit number, we get similar things in expression. Expression you can see later, but we can see the procedure now. 4 into 2 is 8. 8 comes here. 1 into 2 plus 4 into 5 is 22. Like here, given all the expression. 22, we write 2 here and 2 as a carry. Here it becomes longer because it is 3 terms. 100 to unit to 100, 10 to 10, like this one. 3 into 2, 100 to unit to 100, and then 10 to 10. 3 into 2 plus 4 into 3 plus 1 into 5 becomes 23. 6, 12, and then 5. 23, 3 we write here and 2 here. Then we come to this one towards the thousands digit. It becomes 3 into 5 plus 1 into 3 is 80. And finally, 10,000 digit, because it's 3 digit number, so 100 into 100 becomes 10,000. 9 into 9 plus 1 is 10, and that when this is multiply 8 plus 2 has also a carry. So finally, we add there, and you write it, add here, and then we get it the number 100 here. 5 into 5 in them. So 5 into 5 becomes very long. Obviously, it will have the already 10,000, so it will be in crores. $83 crore. So it becomes 1 into 2, 2 is here, 3 into 2 plus 4. I've written here all 1 into 3, 2 into 3. It is from, you can, this particular calculation you can do from left to right or alike from right to left as well. There is no matter how you do, but actually it can be done from right to left or left to right, both. So leftmost digit is 2 into 3 is 6. And then this is 2 into 5 plus 3 into 3 becomes 19. 19 is here. Now 2 into 6 plus 4 into 3 plus 3 into 5, 39. Here it becomes more longer. 2 into 2. 2 into 2 plus 1 into this 2 into 2, 1 into 3, 3 into 4, 3 into 5, 4 into 6. So it becomes 55. 3 into 2, 1 into 2, this way it becomes something like that. After that, finally becomes 1 into 2 is 2. So you add the heat here. The carries were written below and left. Finally, respective carries were added to above, added to the above to get the product. So now we these actually becomes which is below what is very difficult to write here because it is the way it is written. It is very congested written. So better to write. I have shown that better to write in this format, sparse format. So here 1 into 2 becomes this one. The same, probably the same result, same example. Here the 3 into 2, since it is in between, we write it in between. Below this becomes below this. Again, this into this plus this into this plus this, it becomes below this one. This one below this. That way we write, it becomes very clear that which is below what, and then finally you get this 83 crore, this one. Now, this one, there are certain digits above 5. We have to convert it into, suppose you convert this 5, 6 into 5 is not above 5. 5 is 5 itself. But here it's 5, 6. Sorry, 5, 6. It becomes 5. 6. How much? 6 and 4, like this. But this, in that effect, this becomes above 5. So when it becomes 3 and then 6 and 4, again we convert it into vinculum, so it becomes 4 and 4 vinculum, and then becomes 4 vinculum. That's what it is told that sometimes it is, even if it is 5, you have to convert it to vinculum because maybe something is next to it will make it above 5. So this way it becomes 4. This way you convert it into vinculum. 2, 3, 4. This remains. The example I have taken is or below 5. Only this one we converted into this one. We have seen this. We'll see here that if we multiply that, some of them will cancel. 3 into minus 4 and 4 into minus 4. Or say 3 into 4 and 3 into minus 4. It becomes 0. And 4 into minus 4 becomes minus minus 16. Minus 16 will be somewhere here. Oh, no. With that, this one has to be added. These are not the one. 2 into 2 plus 4 into 4. So that way that adds, and then finally that will get much less carry. Here we see carries were higher, but when you convert it into vinculums, carry was much less. And the result becomes like this. You have to reconvert back to normal number. From vinculum, you have to write Nikilam Navatas Sarmadasta. This 4 becomes 3, Eko Nunneno, and then 9 minus 4 is 5, 9 minus 8 is 1, and 10 minus 8 is 2. In the vinculum series, it is the Charamang. The others are not within vinculum. So this Charamang 10, last one will be subtracted from 10. 10 minus 8 is 2. That way you can do. Now, in the next example, I have seen that what is the comparison between various multiplication methods. Suppose you have example 889 into 898. By Urdhva Trijagabham, this becomes very cumbersome. 8 into 8 plus 9 into 9, 8 into 8 plus 9 into 8 plus 8 into 9 becomes 200. This one, 208. 8 into 8 plus 9 into 9 becomes 145. So that becomes very cumbersome. 100 goes up to 100 digits. Whereas if we convert it into vinculums, 889 becomes 1, and then vinculum ones. Here becomes 1102 vinculum. Here we cross multiplication and so on. You find that because becomes very less, and then again reconvert back. This becomes actually this 120. This 322 is there. This becomes 1209 becomes 798 because 1000 minus 798 is 1000 minus 202 is 798. That is the idea. So actually, we see 0 you do not put in vinculum over that, but actually it means that whole thing is negative. 202 itself is negative, so becomes 798. But Nikilam Navatas Charmadasata, this becomes very easy, you see. Minus 112, minus 102. This 112 again, this can be also done again by done this way and becomes 22, but 113. This, since there are 3 digits, this 11, this becomes the carry. This carry here we write, and then we this 889 minus 102 is 787, or 898 minus 111 is 787, and then 11 is added here, 798, 322. Here is Nikilam Navatas. Here we same example, we see conventional method. Conventional method, we have lot of multiplication, lot of this with 8, 9 and so on, lot of multiplication, and then here we get it, your conventional method. But conventional method using vinculums, this minus 2 into this becomes this one. And 0, of course, because I didn't write another A, because there are 2 places we have shifted it, because there is 0. And we write minus 1 into this becomes this one, and 1 into this becomes this one. We simply add it, and it becomes like this, and then finally get this vinculum undone, so that becomes this one. Now it is up to you to choose which method you will use, whether to use Urdhva Trijagabham and with vinculum, or Nikilam Navatas, depending upon your problem, you have to choose between different methods. Given the problem, you can choose various methods. I've just compared. In this case, what do you see that is best method you found? I hope that some people will tell that here the Nikilam Navatas becomes the best method, isn't it? Somebody may have some choice, of course. Somebody may say that no, conventional method using vinculum is the best method. Anyway, that is up to the choice. Okay, so any question from this part? Comparison. Comparison of the algebra of the conventional and Urdhva Trijagabham. These two have there. Given a 3-digit number like this format, these and these numbers, the conventional method, what it does, we multiply everything by R first. Unit digit is multiplied with the whole total of the above number. This is basically, this means that's 4 into this. Then this Q is multiplied with this one with a 1 shifted left. See, this one we put across here. And then we multiply everything by the 100 degrees and put 2 crosses, so that shifted towards left. Then added. So this is the shifting means actually effect of 10 and effect of 100. However, Urdhva Trijya Gautham, what it does, it groups in a different format. In different format, what is that? We collect all the 10,000s, we collect all the thousands, collect all the hundreds, all the tens, and the unity. And then Trijya method has been proved to be more efficient through research. The research, I'll sometimes, if I get it, that paper, I may share it. And share it, I'll just share it in the group. Okay? So homework are given. Please do the homeworks. And choose the best method. It's up to you to choose the best method in every case. Okay. Now, how much time is there?
Another 5 minutes.
8 minutes.
8 minutes.
We can open for questions for.
Please already open for question. Tomorrow I'll do the next one. Like
If you don't have any questions, we'll go start another class.
No, jale. If this is understood, because I think some questions are there, in between I answered them.
Yeah, there is some question. Go ahead, please. Someone is trying to talk.
Oh, yeah. Please.
Good morning, sir. Can you hear me?
Yeah,
yes,
go ahead.
please.
Yeah.
Okay.
Sir, this subject is Vedic mathematics. Can you explain what is Vedic, or how is it originated from the Vedas? I mean, how is the linkage to the Vedas? Because otherwise, these are techniques in terms of computation. So if you can just explain to us on how is it linked to Vedas, or what's the linkage to
this
the whole?
This is actually in detail. He has written in this, explained in this. Actually, you know that we have you went through already so many courses on different theories of Veda and so on. Veda actually came from the whole Veda came from Samadhi, some Samadhi state. Rishis, they are called Mantradhasta Rishis. They found all the principles through their Samadhi state, and then they that passed on to the next disciple and so on. So there is a Vedic method, you can say. Now the Bharati Krishna ji, he meditated on this number system and found that you can say that he rediscovered. Then he found that certain few indication formulas, not exactly in this format, but indications are there in Veda, some in this Atharva Vedakalpa, in some part here it is found. These principles. He also written that he also got it from the same way as the Mantradhasta Rishis got. He also has 7 years of complete sadhana on this number system and so on. Then he found all these things, these principles. He also was expert in modern mathematics. He knew everything. He was an engineer actually, basically, normally, in his previous ashrama. After that, he becomes taken sannyas. So he got all these things mixed money. Compared, he translated in such a format that in a modern people who are doing modern mathematics can understand these things. Main thing is that why it is called Veda principle is that these principles can be translated into a procedure. It is not that that particular expression is there. We never use that. We know that n into n minus a into n minus b that can be used, but we never use as a procedure. So Bharati Krishna ji, he translated it into a procedure, and therefore he, same way as this, it gave, and then there are some small references in about the main sutras. He got Nikhilam Navata, those he got from somewhere, and then he translated into proper accent depending on that. So he called it Vedic method. Therefore, I told you, however, the present person is a result of 7 years of deep study also, from Samadhi also, by Jagadguru Swami Sri Bharati Krishna Chaitanya Maharaj. Any more questions?
Sir, this is a generic question.
Yes.
Why is this not so popular in our curriculums, in the regular curriculum?
No, it is not popular, means it is not just introduced to the course. Now the IITs have then Indian knowledge system, whatever we are learning in the course. There is a, in IIT Kharagpur, they have started a Indian knowledge system, total section is there. There also these are used, these are made popular with some people take high charge and so on, people get interested and so on. But you see that these are the, but what is your own assessment? You tell me your own assessment, whether these are effective or not.
No, it's definitely effective, but it's just a knee-jerk reaction from me that it lacks perhaps a structure which can be easily understood. Okay.
Like the structure?
Unlike the sound mathematics that
no, because
the foundation, maybe we had too much to digest, I guess.
No, because you are learning in something different, new. See how do you remember how many years, how many months? You should not say years. How many months you spent in the childhood to learn the procedure of multiplication, division? Do you have any idea? Or LCM, GCF, and so on?
No, sir. So what I mean to say, for example,
that much time you have to give.
No. What I mean to say is that I'll tell you. 25 into 25. Basically, the rule is the last two digits. 25. 5 into 5 is 25. 2 into 3 is 2 into 3 is 6. So therefore, the answer is 625. But that cannot be extended to any other multiplication. You see this? So that means there is some fallacy there. It's just limited. Can we tell you why it is 2 plus 3? 2 into 3. If I look at 25 into 25, it is basically the shortcut.
No, the algebra is there. Algebra is there. See, algebra is there.
Yeah. I mean, maybe that's what I'm saying. Where is this
the
foundation?
What you meant to say, change algebra gives rise to change procedure. Here, this particular algebra is noted down that always it will be ending at 25.
Correct.
No, there are some cases like that. Because there's so many things have to be discussed or didn't do. So, like this also. No, actually, this one I think. This one I'm not practicing that much. I cannot say it. Like this kind of procedure, this can also be done this way.
Sir, the same thing doesn't hold good for any other non-5 numbers. For example, 16 into 16. This formula doesn't work.
There is some other classes also there. It not only ended in 5 but something else. Here also, this becomes this into this plus 1. 7 into 8 is 56, and this 7 into 3 is 21. This is possible. Where actually this number is same. Like here squaring, this is same. This is same into 25 into 25. Here it is not. It's from 75 into 75, we are doing 73 into 70, which is 10 minus 3. 10 minus 3 is 7. So here also this principle follows. There is this kind of limitation. This is a class of multiplication for this one. But actually more general is so many things. So I have in this I have covered so many different methods. This was only one method. In particular situation where it is 10 minus 5 is either ending in 5 means 10 minus 5 is also 5 that way. But it's 10 minus something is. Suppose it is 4 and 6. If you get 4 and 6, if you write, answer will be 56 and then 24. Okay. So that way you can see by calculating one, you can do calculating a class of them together. 305 and 305, 305 into 305 is discussed here. You tell me what is that? Somebody can tell? Very easy. 304 into 306. This will be same. 930, but it will be 24. Where you write, here it will be 24. Here you write 3, you write 7. It will be 21. You write 2 here, 8, it will be 16. 1 and 9, it will be 09. Same thing, same base, 912. So you get a different insight. You don't have to recalculate a class of the things in the same way, but you do get number system in a different perspective. That is the idea of this Vedic mathematics. You can say that it is intuitional mathematics this way. Okay.
Okay. Thank you.
Also, this is a particular class, and then you get another particular class near a base, above a base, near a sub base, and then general one, where you what you do? Here is all near a base or near a sub base, and finally you get a more general multiplication method where it is general method, but we are doing a different combination. By doing different combination, it becomes actually faster. If we translate it into a circuit, this becomes faster. It is seen. So, what more you want from Vedic mathematics? In terms of multiplication. Tomorrow we'll do division. We'll do division. How division can be done most effectively? Again near a base, above a base, below a base, and again general method of division. But general method of division is slightly more complicated, and that is covered in the second level. Then we'll after division we'll do that. After division we'll go to recurring decimal. Recurring decimal will be surprised that why such a easy method is not taught in school. I'm really surprised for recurring decimal. And in case of recurring decimal, there will be a lot of things to be learned in recurring decimals. And then divisibility. You know, we learned from the childhood, we learned divisibility. Divisibility only with how many? Only few numbers, 3, 9, 11. Of course, 2 and 5 are there. 2 and 5 are the components of the base itself, base is 10. And 3, 9, and 11. And then we write, we understand, learn composite numbers like 6, 15, etc. But we do not learn about divisibility by 7, 13, 17, 19. But those are also very easy. Those are in the same line as 3 and 11, 3, 9 and 11. But in the 3, 9, this some component called vinculum is some component called this oscillator is 1. But when the oscillator becomes 2, in case of 19 and 21, we just skip it. We do not learn.
Okay, sir.
Why?
We will see this in the next
maybe a third session or fourth session. Towards last.
So now shall we go for Prarthana, sir?
Okay.
Okay.
Thank you. Stop sharing.
Yeah. Krishna Kumar garu, Prarthana, please.
स्वस्ति प्रजाभ्यः परिपालयन्तां न्यायेन मार्गेण महीं महिषाः ब्राह्मणेभ्यः शुभमस्तु नित्यं लोकाः समस्ताः सुखिनो भवन्तु काले वर्षतु पर्जन्यः पृथिवी सस्यशालिनी देशोऽयं क्षोभरहितो ब्राह्मणाः सन्तु निर्भयाः अपुत्राः पुत्रिणः सन्तु पुत्रिणः सन्तु पौत्रिणः अधनात् सधनात् सन्तु जीवन्तु शरदां शतं सत्यं वद धर्मं चर स्वाध्यायान्मा प्रमदः सर्वे भवन्तु सुखिनः, सर्वे सन्तु निरामयाः, सर्वे भद्राणि पश्यन्तु, मा कश्चित् दुःखभाग् भवेत्। ॐ शान्तिः शान्तिः शान्तिः। ॐ पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते, पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते। ॐ शान्तिः शान्तिः शान्तिः। सर्वे जना सुखिनो भवन्तु। స్వస్తి.
ధన్యవాదములండి కృష్ణ కుమార్ గారు. నౌ లెట్ us రిక్వెస్ట్ చల్లా చిట్టిబాబు గారు టు recite జనగణమన ప్లీజ్.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता, पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल बंगा, विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा, तब शुभ नामे जागे, तब शुभ आशीष मांगे, गाहे तब जय गाथा, जनगण मंगलदायक जय हे भारत भाग्य विधाता, जय हे जय हे जय हे जय 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 हे जय हिंद.
జై హింద్.
जय हिंद.
ధన్యవాదములండి చల్లా చిట్టిబాబు గారు.